Hello everyone and welcome back to the course. In this lesson, we'll take a look back at everything we've learned throughout the course and see how we can put it all together. We will also look at some examples from my own assets so you can see how these concepts can be applied in real-world projects. Let's get started. Now let's review all of the areas we've covered throughout the course. We started learning some foundational knowledge such as object-oriented programming and inheritance. We also learned about class composition and the difference between the event graph and the construction script. We learned about data, about the different data types available in Unreal Engine. We learned about arrays, how to use them, and some best practices. We also looked at some user-defined data types like enumerators and structures. We learned about execution flow by looking at nodes such as the sequence node, the branch node. We learned about loops and about the select statement. And we also learned about the flip-flop node. We also learned about ways to separate our code to keep it modular and reusable. We learned how to create functions, custom events, and our own custom actor components. We learned how to interpolate our data between two values. We used the nodes interp2, we used lerps, and we learned about timelines. We also learned how to control the timing of our code by using delays and timers. We looked at how we could gather external information for our blueprints by using overlaps and traces. And we also learned how to communicate or send information between blueprint classes by learning about direct communication, blueprint interfaces, and event dispatchers. Now let's look at these topics from a more practical perspective based on your needs as you work on your project. If you need to store data, you can create variables of specific types. For example, the player's HP or the number of coins collected. If you need to group different data types together, you can create your own structure. For example, you can group all of the related settings for an object. If you need to store a list of items, you can create an array of a specific type. For example, the list of keys collected by the player. If you need to make a binary decision or a yes or no decision, you can use the branch node, also called the if statement in programming. For example, does the player have a key? If you need to repeat an action multiple times, you can use a loop. We looked at the for loop, the while loop, and the for each loop. For example, you could go through all the keys in the level, and if all the keys have been collected, you could then unlock the door. If you have a list of items or states where each one has a different course of action, you can use the select node, also known as the switch statement in programming. For example, if you need to display a different message depending on how many keys the player collected, you can use the select statement. If you need to control when the code is executed, you can use a delay or a timer. For example, you want to check the player proximity on an interval. If you need to interpolate smoothly between values, you can use the interp2, the lerp node, or use a timeline. For example, you want to move a platform to a target location smoothly. If you need to get external information for your blueprint, you can use overlaps or tracing. For example, you could trace for objects in front of the player so you can interact with them. If you need to pass information between blueprints, also known as blueprint communication, you can use direct communication or casting, you can use interfaces, or you can use event dispatchers. For example, if you want to call a function on another blueprint, you would use blueprint communication. And if you want to create generic code that can be used by multiple blueprints, you can create a custom actor component. For example, you could create a generic destruction component that you can attach to any number of blueprints that would take damage and destroy its parent. Now I'd like to mention some additional topics that were not covered in the course, but I consider to be quite important. I may cover these topics myself later as additional videos, but for now, I would like to mention them here. If you need to manage large amounts of data, you can use a data table. For example, if you're creating a loot drop table for your game. If you want to display something on the screen, you would use a widget. For example, you would like to create a HUD for your game. If you want to save and load data to and from disk, you can use a save game object. So for example, if you wanted to save your game progress to disk. And if you wanted to control multiple characters, you would use the possess node. For example, you would like to control multiple vehicles in your game. I highly suggest you look into these topics further after you finish this lesson. And now let's jump into Unreal so I can show you some practical examples from my own assets. Alright, and here we are in one of my most popular assets, the Animal Behavior Kit Pro. I'm going to use this to show you some of the principles we've learned about throughout the course. Let's start with some of that foundational knowledge we learned about way early in the course, and I'm talking about things like object-oriented programming, inheritance, class composition, etc. This is a great example of how to use inheritance when we're talking about creating different categories of animals. And right here in the project, you can see that I have a base animal class. And if I open this right here, you'll see that we have derived this class from the character class. That way we have the character movement component, etc. I've added some widgets for the HUD. You can see that we have the skeletal mesh here, even though it's empty. And if I go to the event graph, you see that we have some information here, mostly about taking damage and dying. That functionality is common to pretty much any animal in the project, so I decided to put that damage code and death code right here. If you look at the variables that we have a struct called simulation details. And if I open that here, you can see that we have things like the AI run mode, radius to activate, the player check frequency, inactivity options, etc. We have some animal details that are common to all of the different animals, and the options show HUD, show the animal name, show the animal HP, some colors, even the animal name here, and what kind of species and the sex and the animal HP. All common information that every single animal in our game should have. And if we dive deeper here into the ground animals, we have a base ground animal class. And if I open that here, you can see right here that we have some additional components. Now we have a camera and a spring arm. We have some additional volumes for attacking and for overlapping for AI. We have a widget for taming, which is only available in the ground class. We have a lot more variables. For example, we created a structure called random appearance, and you can see that we have some options here, like a boolean that says, hey, do you want to randomize the size of the animal? We have a range. Do you want to randomize material for the animal? And then we have an array of materials here that we can apply. We have some enumerators, for example, the roam behavior. And if I click here, you can see that we have many different behaviors for the animals. Stay in place, go to a random location in the nav mesh, go to a random waypoint, go to the nearest POI, etc. So you can see how I'm using enumerators here to easily tell the developer what kind of behavior do you want your animal to have. And I'm using structures here to keep all of the same related settings and information in a very nice category that you can collapse. So if I go back to my level here and I select any animal and I go to the details panel here, you can see that that information is right here, all organized, random appearance, engage tags, etc. Everything that is related stays nice and neat. Random movement, for example, has all of this information. If I go back to the ground animal class, let's go to the event graph here. You can see that we have a lot more information compared to the base animal class. This is perhaps the most complex class in this project because most of the animals are going to be ground animals. That is the focus of this project. And if I go and open the graphs here, you can see that we have a lot of custom events. For example, we have an event called event dead, and we have a lot of things that are happening here once the animal dies. We want to reset some states, we want to set the state dead to true, we want to add some tags that tell us that the animal is dead, we want to see if the animal, once it dies, we want to ragdoll the body or not, etc. We also have a lot of functions that we're using. If you can expand here, you can see that we have a lot of functions that do many different things. For example, we have a function that disengages the animal, another function that does melee damage, and if we open here, you can see we again are using a debug animal struct to see if we are in melee range, and then we go here and we use enum and a switch statement here to do different things, or a select node here. If the damage is single damage, we have an execution pin and we do certain things, and if the damage is AoE or area of effect, we do some other things. So if it's single damage, we do a single sphere trace for objects, and if it is AoE, we want to hit more than one target, we do a multi-sphere trace for objects. So you can see how these things can easily be applied to a project like this. And we looked at this in a previous lesson. Once we get the actual overlap actor, we simply apply damage with a damage amount from this separate struct called behavior details attack. If we're doing this on a multi-sphere trace, you can see that we have a for each loop, and for each individual overlap actor, we are then applying the damage. Same principle, but you can see here how we're using different types of traces, and in this case a loop, to do the exact same thing multiple times. If I go to the class defaults here, you can see that I'm also using, class settings. You can see that I'm also implementing 3 different interfaces for our animals. And if I go down here and I expand the interfaces menu here, you can see that we have a lot of different things that we are doing via our interfaces. So there's a lot going on here, and I'm using interfaces, I am using custom events, and I'm using functions deliberately to get that functionality compartmentalized into reusable code that can be called from other blueprints or called on demand. If I go back to our map here and we go from ground animal, we can actually go into prey or predator. That's the next level down. So if we go to prey, for example, I have the BP prey AI, and right here you can see that we have it as a child of ground animal base, and you can see now that we have the same components, but now we have the actual static mesh. In this case there's a deer, and if I go to the event graph, there's actually nothing going on here. In this case, instead of adding additional functionality for this blueprint, all I'm doing is simply setting all of the options here for a prey. The same thing for the predator, for example. I am not adding any additional functionality. In this case, we have this bear. If I go to the event graph, you can see that nothing additional is really happening, but instead I am adjusting all of the different settings here from our ground animal base. And we can take it a step further. Even on the prey category here, we have BP prey AI. We can take that and further divide it into male and female. And even then we have a young version of a female and a young version of a male. So you can clearly see how I am subdividing all of the different categories, starting with a generic animal base, going to a ground animal base, then breaking that down into prey and predator because those behaviors are very different. And further down, I am subcategorizing all of the animals so I can further customize each individual class. Another thing that is interesting to note here is that I use a lot of components. So if I go back to blueprints here, and I go to the AI folder here, we have a components folder. And if I open here my ground animal components folder, you can see that ABK uses a lot of different components. For example, there's a component to spawn loot. That code was deliberately separated here to keep things, again, organized. So if you want your animal to spawn loot on death, you simply add this component. If I just open the component right here, you can see that it's actually fairly simple. We have a special event called event spawn loot that is called from the ground animal class upon death. We get the owner. If you recall from a previous lesson, this is one of the most common nodes that you will use, that I am casted to the ground animal base class here. So no matter what kind of animal, whether it's a prey or a predator or any other child blueprint, as long as I'm cast into the ground animal base, this reference will be valid. I am saving it as a separate variable. And then I am going through a loot table map. We did not go through this in the course. This is a little bit more advanced, but I'm grabbing a class that I'm going to spawn for my loot. I am then grabbing a % chance of this spawning. I am then using a line trace by channel. And what I'm doing is I am getting the owner, I am getting the actor's location, and I'm getting a random vector, and I'm multiplying the X and the Y directions that are going to be random by a spawn range. And I am again making a vector using this as the X, the Y, using the owner's Z value or height as the Z. And then I'm adding this all together and adding 20,000 in the Z. That will be the starting location. And then what I'm doing here is I'm adding a negative 40,000 in the opposite direction. That would be the end location. Effectively, I am choosing a random location around the animal that just died, spawning a trace, going all the way up very high until I hit the floor. That would give me the actual location where I want to spawn my loot. The reason I do that is because if you're in a landscape with mountains, you don't want the loot to clip through the floor or spawn somewhere that it's not supposed to be. So you always want to make sure that you get the actual location in the world. So that's just one example of what I'm doing here. Another interesting component here, I'm going to go back one level, and there's an all animals component. If I open here, we have a component for the day-night cycle, which also comes with the animal behavior kit. So if I open this, I'm going to go all the way to the event graph. We are using event dispatchers in this component. And remember, event dispatchers are a one-to-many communication. So we have a day-night cycle blueprint that is going to live in the level, and that day-night cycle will have event dispatchers that will tell the animals when the day started and when the night started. And then the animals can subscribe to that event, and they will be notified when the day starts and when the night starts, and they can then react to that information. So here on event begin play, I have a custom event called bind to dispatchers. And if I open here, you'll see that we have whether this component is active or not, whether the reference mode is manual or automatic. If it's manual, you will put the reference to the night cycle blueprint yourself. If not, I have a function that will grab it. We check whether it is valid, and then we bind, as we've done this before, to the event dispatcher day started, and we bind it to a function called bind day started, and we also bind to the event dispatcher disp night started into a custom event called bind night started. And if I go out here, now we have two different events that will be triggered. So when the day starts, if I open here, you'll see that we have now an animal type enum that we have here, ground animal, flying animal, or swimming animal. And I'm using a switch statement or a select statement here, select node, to toggle between the different kinds of animals. If this is a ground animal, we want to do something very different to modify the behavior compared to, let's say, a flying animal or a swimming animal. So again, another example of how to use your own enumerator to change the coding path inside your blueprints. So if this is a ground animal, we are going to come here. We're going to grab the owner, cast to ground animal base, because now we know that this is the path for a ground animal. We're going to see whether the animal is active during the day. If true, we go here. If false, that means that it's a nocturnal animal. We use a sequence node to do a few things like activate the group component, and we set the biggest need. If this is an animal that is supposed to roam during the day, then we set the behavior, the biggest need to roam. But if it's false, then we make the animal want to rest. If you want to practice what we learned, look at the areas covered by the course and think of additional examples where you can use what you learned to build simple functionality. In addition, I recommend you learn the following topics on your own: data tables, widgets, the save game object, and how to use the possess node. These are topics that I'd like to cover in the future, but I still consider them to be quite important when creating functionality. In addition, I will include a link to images of the topics covered in the course in the Programmer Toolbox table in the video description. Feel free to use them as a cheat sheet when thinking about creating functionality. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.